Day 611 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1390 for divisors. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array nums, return the sum of divisors of the integers in that array that have exactly 4 divisors. If there is no such integer in the array, return 0. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, input nums equals an array of integers, 21, 4, and 7. The output is 32. The explanation says 21 has 4 divisors, 1, 3, 7, and 21. 4 has 3 divisors, 1, 2, and 4, and 7 has 2 divisors, 1 and 7. It says the answer is the sum of divisors of 21 only. So once again, it says right here, we want to return the sum of divisors, we want to return the sum of divisors of the integers in the array that have exactly 4 divisors. So 4 only has 3 divisors right here, listed right here, and 7 only has 2 divisors listed right here. So 21 is the only integer in this array right here that has 4 divisors, right? 21 exact, because we want exactly 4, not more, not any more, or not any less. And then once we have those 4 divisors, which are listed right here, we want to add them all together and return the sum. So in this case, 1 plus 3 is 4, 4 plus 7 is 11, and 11 plus 21 is 32, and that's how we got our output of 32. Now, just in case that didn't make sense, let's take a look at example 2. In example 2, the same principles apply. So in example 2, we have our input nums equals an array of integers 21 and 21. Same thing, we already know 21 has 4 divisors, right? Because they tell us up here in example 1. But this time, we have two 21s, right? So since we have two 21s, that means we need to get the sum of the divisors twice, right? So this sum of divisors would be 32, but then we added to this, we need to add this sum of divisors, which would be 32 plus 32, which in the end is 64. So that's how we got the output of 64 here. We just took the sum of divisors of this 21 and added them to the sum of divisors in this 21. So it's important to note that even if the same integer appears more than once, we still have to include those sums in our output. Now let's take a look at example 3, where they may try to throw a trick question our way, and there is no such integer in the array, so we return 0. So in example 3, our input nums equals an array of integers 1, 2, 3, 4, and 5. The output is 0 because there are no elements in this array that have exactly 4 divisors. And since there are no elements in the array, then we're just going to return 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we want to do is we're going to track the number of divisors, or we want to keep track of the number of divisors for the current number. So we could store that in a variable. So we'll just create a variable, call it ands, colon, and we'll set it equal to 0 just to start. Now we need another variable to store the sum of all divisors for the current number. So we could declare a variable called sum, colon, that could be an integer as well, and we could set that to equal to 0 to start. Now we need a variable that will accumulate the total sum of divisors for numbers that have exactly 4 divisors. So we declare a variable here, call it total sum, and once again, say colon, cast it as an integer, and set it, initialize it with 0 just to start. Now we need to iterate through each number in the input array by index. So we're going to say for j in 0 dot less than nums dot count. We're going to open up the brackets And we need to reset the divisor count and sum for the current number. So we'll say ands equals 0, and we'll say sum equals 0. Boom. And then we're going to iterate only up to the square root of nums of j because divisors come in symmetric pairs, and so I and nums of j divided by I. So we'll come right here, we'll say for I and 1 dot dot dot, say int, open up the parentheses, say sqrt to get the square root, open up the parentheses, we're going to say double, it'll be a double, open up the parentheses again, and we'll say nums square bracket j. Boom, come outside of that, open up the brackets, and we're going to check if I is a divisor of nums of j by saying if nums square bracket j mod I equals 0, then we're going to open up the brackets, and if I is exactly the square root, it contributes only one unique divisor. So we'll say if nums square bracket j, come outside of that, divided by I equals I, then we'll open up the bracket and we'll say ands plus equals 1, come underneath that, and we'll say sum plus equals 1. Boom. Then we could come right here and we could say else, open up the brackets, and we'll count both divisors. So we'll say ands plus equals 2, and then we'll say sum equals sum plus I plus nums square bracket j divided by I. Boom. And if the current number has exactly 4 divisors and its divisor sum and its divisor sum to the total, then we add its divisor sum to the total, we're going to come right here, and we're going to say if ands equals 4, we'll open up the brackets, we'll say total sum equals total sum plus sum. Boom. Then we need to return the final accumulated sum by coming right here, and we could just say return total sum. Boom, y'all. That should be all she wrote. So let's give it a run. Make sure it runs properly before we submit it. Oh, when we have an error. Sorry, y'all. Should be total sum like this. Boom. Now let's run it. See if that does the trick. Okay. Can I find total sum and scope? So let's see. Oh, there it is, y'all. Boom. Now let's run it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And boom, look at that, y'all. 27 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.